Hey guys, here's the deal. We're going to do PreCalc 5.1, and hopefully you're doing this at home tonight, the night after the test. And we got PreCalc 5.1 fundamental identities. I will be able to identify and work. Hey guys, hope things are going well. I hope you're having a wonderful evening. We're going to look at PreCalc 5.1 fundamental identities. Okay, after this, I will be able to identify and work with trigonometric identities, basic trigonometric identities, Pythagorean identities, co-function identities, odd and even identities. Now remember these. We've talked about co-function, we've talked about odd and even. Pythagorean theorem we've touched on, and the basic trig identities we kind of covered as well. We're going to look at simplifying trigonometric expressions using the above identities and solve the trig equations using trig identities. Okay, sorry, Janan just came in. So we got that covered. Solve trig equations using trig identities and properties of algebra. So now, first thing I want to do, check out example 0. Without having a unit circle in front of you, give the simplified exact rationalized answer. Go for it. Try it on your own, and I'll bring it up. But you got to work unit circle on your own. You got to know these. These have got to be boom, 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 boom. So turn it off and turn me back on when you're done. Hey, welcome back. Sine of 2 pi is going to be 0. We got cosine of 3 pi over 2. You got to think where that is, and that's going to come out with a 0 as well. Now, tangent of pi over 6. Pi over 6, when we're talking about it, and that's something that's really tough for folks when we're looking at pi over 6. So pi over 6 is right over here, and we're talking about the fact it's the square root of 3 over 2 and 1/2. Tangent, however, is sine over cosine. So it's going to be 1/2 over, well, 1/2 times. Since it was 1/2 over the square root of 3 over 2, it's 2 the square root of 3. So this is 1 over the square root of 3, and if I rationalize it, it's the square root of 3 over 3. Okay, so 7 pi over 4, cotangent, which is really cool, but remember 7 pi over 4, this is 4 pi over 4. As I go around the circle, I got 4 pi over 4, and I got to go 3 more. So generally that's -1 as I'm talking about it for tangent, and it's also -1 for cotangent. So next one, we're looking at secant of 5 pi over 6. 5 pi over 6, remember 5 pi over 6, the location of 5 pi over 6 is right here. And I got 5 pi over 6. Hopefully you're thinking, well, that's the square root of 3, negative square root of 3 over 2 and 1/2 below. Okay, but secant is 1 over cosine. So if I've got a cosine of 5 pi over 6 is equal to negative square root of 3 over 2, the secant is the reciprocal of that, which is -2 over the square root of 3. Well, I can't have the square root of 3 on the bottom, so I've got to go to the square root of 3 like that. So it's 2 the square root of 3 over 3 as I go through, and that's where I'm going. Okay, now for my cosecant of 5 pi over 3. If I'm talking about cosecant, that's 1 over sine, and I've got 5 pi over 3, so that's 1, 2, 3, 4, 5, and I'm looking at the idea that 5 pi over 3 is 1/2 and the negative square root of 3 over 2, and cosecant's 1 over sine, so it's reciprocal. So I've got -2 square root of 3, and it's going to be -2 the square root of 3 over 3 as I get there. And now I got cotangent of 4 pi over 3. So all this stuff is review, but remember, I'm just throwing out stuff we should already know. And it's frustrating at this point. You know, if you don't know that, I suppose I should pop that back in there. It's frustrating if you don't recall it, but remember as we're working, get going on that unit circle. That is your bread and butter in these chapters. So I've got cotangent, which is the reciprocal of tangent. So I'm looking at 4 pi over 3. So if I'm looking at 4 pi over 3, I'm right here. This is 4 pi over 3. Okay, that is -1/2 negative square root of 3 over 2. And remember, tangent sine over cosine, cotangent's cosine over sine. So I've got my cosine, and over sine is over the negative square root of 3 over 2. But that's the same as, if I flip it around, it's -1/2 times -2 over the square root of 3, which is 1 over the square root of 3 there. And I'm going to multiply top of my square root of 3 over 3 when I'm done. okay? Secant of pi over 6. So secant of pi over 6 when you're coming through there. Again, secant, and I got pi over 6. Well, secant, keep in mind, is 1 over cosine. And, excuse me, I'm not saying pi over 6, it's secant of pi. Pi is over here. And remember, that's negative 1, 0. Well, that's just going to be negative 1 because cosine's negative 1. 1 over negative 1 is just negative 1, if we can get that up. Now, the next one is 7 pi over 6 of sine. So 7 pi over 6 of sine. 7 pi over 6 is down here. Remember, that's 7 pi over 6. Sine is the second one, and it's negative 1/2. Cosine's negative the square root of 3 over 2. Sine's negative 1/2. And that's all I'm going, so it's negative 1/2. So cosine of 2 pi over 3, cosine of 2 pi over 3, remember where 2 pi over 3 is located? Hopefully you already got it. 2 pi over 3 is 1/2 negative and the square root of 3 over 2 when I'm doing this. So remember, that's just going to be negative 1/2 when we're done. And I just kind of ran through them kind of quickly, but I gave you pictures of where things were and then gave you the answers to follow things up. So I'm hoping that you're following along. If you're not, gosh, whiz-bangerings, let's talk about unit circle and let's talk about the issues we're having because we got to get rid of them. Okay, let's go on to this next piece. We're looking at the fundamental excuse me, my cursor's bouncing all over the place. Okay, so we're going to lock this in place. We don't have those issues anymore. So now here it is. The symbol equals means several different things. Equality of numbers, 1 plus 1 equals 2. It's a true sentence. Equivalent expressions, well, these two are equal and therefore I can find my value of x. Well, open sentence. Well, this squared plus 3 equals 7, so x is 2. It can be true or false depending on what x is a solution to the equation. Okay, identities. This is the same as this. Now, a couple things about this. This is the way you see things. This is called one of the Pythagorean identities, but we have seen this written this way. And since it's t, I'm going to write it like this. Notice how it's rewritten shorthand. These are equivalent identities. Okay. Now, we are seeing it as in equations that equate two expressions that are true for all values in the domain of both expressions. Domain of validity, values of the variable for which both sides of the identity equation are defined. Okay, so we've talked about equality, we've talked about the beginning of identities, and now let's talk about some basic trig functions, or trig identities. Now, we've already talked about cosecant theta, and cosecant and sine are reciprocals of each other. And matter of fact, I've got sine again over here. That's reciprocal cosecant. So, you know, it makes sense. Secant and cosine, reciprocals of each other. Cotangent and tangent are reciprocals of each other. Tangent, keep in mind, is sine over cosine. And I've said that several times because remember, tangent's opposite over adjacent and sine's opposite over hypotenuse and cosine's adjacent over hypotenuse. And when we knock each other out, it really comes down to opposite over adjacent. Cotangent is adjacent over opposite. So that's just the reciprocal of tangent. So keeping that in mind. Okay, so now what we're going to do, we're going to look at the reciprocal identities and the quotient identities. And we're going to talk about answering questions with the idea of things equaling, theta equals 0, and whether it's defined, the domain of that function is defined in that area. And let's talk about specific questions. So in number 1, we're talking about the fact that theta is equal to 0 is in the domain of validity of exactly 3 of the basic identities. Which 3? So let's put 0 in for theta in each one. And now what they're saying is in the domain of validity of exactly 3 of the basic identities. So it's in the domain of each of them. Okay, secant, cosecant. So when I'm talking about 0, the cosecant of 0 is undefined, because I'm dividing 1 by 0. The sine and cosecant, same reason. I can't do it. But here the cosine of 0 is 1. The secant of 0 is 1, so that works. So now we're looking at cotangent. Cotangent, however, when I'm looking this over, it's cosine over sine. So the cosine of 0 is 1, but the sine is 0, so it's undefined. And here, if I look at tangent, the tangent of 0 is sine is 0 and cosine is 1, but that's 0, but 1 divided by 0 doesn't work. Okay, so as we go through this, we got to recognize some things that work on both sides, some more things that work on one side, and we're going to answer those questions. So here, isn't where theta equals 0 is in the domain of validity of exactly 3 of the basic identities. Which 3? Well, as we went through this, we saw it was in cosine and secant. Okay, we also saw that it was in secant and cosine. But now, when we finish this off, we got to keep in mind that it's also in tangent. Okay, so as we look through, we have that it works on both sides with tangent, secant theta and cosine theta. Now, for exactly 2 of the basic identities, one side of the equation is defined at theta equals 0, and the other is not. Okay, well, we did that as we went through, and if we remember, it was sine of theta and cosecant theta. Sine of theta is 0 at 0, but cosecant, okay, which is 1 over sine of theta, isn't set up there because we're dividing by 0 here. So that's not going to work. You know, cosecant is 1 over sine, and 1 over 0 doesn't work, and 1 divided by 1 over 0 is not going to work out at all. And the other side of it was tangent of theta, okay? Because when I do the tangent of theta equals 1 over cotangent of theta, it works on tangent of theta because that's sine over cosine. But cotangent of theta is cosine over sine, and with sine being 0, it's undefined. And 3, for exactly 3 of the basic identities, both sides of the equations are undefined. Both of them are undefined, so it doesn't work on both sides. So we're talking about 3, and it's cosecant, cotangent, and cotangent with theta. Anytime we have a 0 in the denominator. So here I've got 0 in the denominator on both sides because cosecant's 1 over sine and 1 over sine. Although that's 0, it's 1 divided by 0. Cotangent is cosine over sine, and that's where I have 1 over 0. And here I've got 1 over tangent. And if I got that tangent, I'm going to bring this up. My arrows keeps bouncing away from me. I'm looking at this. This is sine over cosine. So sine of 0, cosine's 1, but that's 0, and 1 over 0 is undefined. And this again, because we had cosine over sine, that's cotangent, we got 1 over 0 again, so that's undefined. Cotangent of theta is 1 over 0, it's undefined. And this is 1 over 0, and yet, again, it's undefined on both sides. Okay? And I know all that information from working with the angle measure 0 and the cosine and sine values of 0 are 1 and 0. And that's really what I was working through throughout this entire activity, this exercise, back to the unit circle. Okay, now, Pythagorean identities. Okay, and people are like, what? Pythagorean identities? These are identities that are Pythagorean theorem. Now think about it. We got cosine squared theta plus sine squared theta equals 1. And when you look at it, when we've been doing the unit circle, we had the cosine of whatever your theta was. We've had the sine of theta. And remember, this is the unit circle. That's 1. So when we're looking at that, that's the cosine squared theta plus sine squared theta was equal to 1. Okay? And that's how we are able to come up with our unit circle stuff. So these all three tend from our unit circle work. Please keep in mind, I can derive each one of these, the other 2, from this one. I'm going to show you how to do it, and I'm going to do it quite often with quite a few of the problems we're going to do in this example. But finding the 2 other Pythagorean identities from cosine squared theta and sine squared theta equal 1. So first thing, and I'm going to rewrite this the way you're always going to see it, because I want to make sure you see exactly how you'll see it every time I write it. These are synonymous. The red is what I expect you to know. But here's the thing. I'm going to take cosine squared theta plus sine squared theta equal 1, and I'm going to derive one of the others by dividing by cosine squared theta. So I'm going to divide by cosine squared theta all the way across. Or cosine squared t, I should say. Now keep in mind, what I'm doing here is when I divide, let me get my little cursor back here. When I divide cosine squared t divided by cosine squared t, well, that's 1, right? Well, that's kind of cool. And then I got sine squared t divided by cosine squared t. We found out that on the previous page, that's tangent squared t, okay? And that's going to equal secant, because that's what 1 over cosine squared is. So that's secant squared. So this equals secant squared t. Well, gosh, that's that one, okay? When I take this next one, remember, again, cosine squared t plus sine squared t equal 1. That is the basic Pythagorean theorem, one of the Pythagorean trig identities. I'm going to divide this one, however, by sine squared. Okay, see what happens. Sine squared t, and let me get rid of that little check mark. Sine squared t. Keep in mind what's going on here. This is cosine squared t over sine squared t. Well, we just learned about that. That was cotangent squared t plus sine squared t divided by sine squared. That's just 1. And then I've got cosecant squared t.